Alright, so this is an example here of a blank rapidminer canvas on which we will create a process using the various operators for pre-processing, just to see what the text looks like. So first step is to get our data, and I already imported into the local rapidminer context. So for me, all I will do here now is insert an operator, process documents from files, so this one right here. So drag that onto the screen. Now let's go back, specify where this directory is pointing to. So create one for the positive class, and we'll see here. Bring in that entire folder, and that will be for the positive class. And now we'll do the same for the negative class. And only in that folder is just the CSV that I had shown earlier that has the individual instances of tweets. Alright, so there you go. Data's brought in. Now we'll double click within this operator, because some operators in RapidMiner sort of have sub-operators, and you can click within them and then add other operators to the process within it. And we'll add a few familiar concepts which we've come across in this class. So transform cases, get everything to lowercase. All right, we'll bring this port to here, and that's a good concept to point out. A good analogy for the way these sort of drag and drop interfaces do things is, think of pirate ship or something like that. Ships going from port to port, and these are the individual streams which connect them. So these little semicircles on the sides are called ports, and that is the class object that's being passed from operator to operator. So in any case, we now transform cases to lowercase. That's what we want. Very good. Now we will tokenize. That's another thing we've come across. Again, we'll connect the port. And I'll add in a breakpoint after, so you can sort of see what the output for the tokenization is. Again, I'll connect this port. I will run the process. Now here it tells me the connection is missing on that outer process, that very first one, and so it gives me the suggestion to fix now, and I'll do that. And now I will run. This takes a little bit, so we'll see what comes up here. So there, it finished running, and we can see the results. And you can just see that tokenizer, just for every other word, changes colors, telling you what was tokenized. And so there you have it. So now we'll add in a few other operators that correspond to some of the other concepts we learned in class. So let's see, how about we add some stop word filterization now, and we'll just use the one in English. Also remove this breakpoint since we don't need that anymore. And we will also, this is a little problem I've sort of seen running into using RapidMiner. For whatever reason, the library they use for stop words doesn't include I, as in our word for me or whatever. So that one has to be filtered out manually. And so you can do that by looking in this file, and I have that saved precisely in that same directory, more or less. And this custom stop words there is just, well, there's only one character in that text file, and that character is I, so it tells it to exclude I. So we'll add that one. What else can we add here? You can also add n-grams. That is also one of the functionalities. I won't do that here because it'll take a little too long, but if you had a little more defined process with less data, or more computing power, it wasn't in a presentation context, that would certainly be An intelligent thing to add for sentiment analysis is throwing n-grams on there, and I'll just drag it onto the canvas so you can see. You can choose between characters or terms, that is our tokens that we've designated as words, and you can designate a max length if you were so inclined. So 2 words, or 2 tokens, 3 tokens, etc. Let's get rid of that. And I think that is all we want to see here. So I'll connect this again to the flow, make sure everything's okay here from the process, and run it. I will run it again. And there you go. That was a little quicker since it didn't generate the example. And you can see just word counts. So let's see what the most common word count was. S, I'm assuming that's an apostrophe S, the way it's been usually handled. Love, very frequent one. That's probably, as you can already see, that's most likely going to be, when we end up assigning sentiment to these, that's probably going to be found in the positive sentiment most of the time. So yeah, very common words. Happy, another one, and same deal of having positive instances far outweighing negative. You can even see along those lines, if it's positive, what's the most frequent occurrence? And again, it's love, happy, good, mothers. That's sweet, I guess. And then how about negative? What's common negative words? Hate, that's not surprising. Work, also not surprising. Sucks is another good one. No. So yeah, so that is it for the pre-processing side. Now we will move to a separate part to deal with the actual sentiment analysis. All right, so now we'll move on to the actual sentiment analysis part of things. You'll notice the structure is a little slightly different here. It needs to be tuned a little, just because that makes it a little easier, and I don't want to have to, go through that particular part because it's not very instructive to the actual usage of the actual application of NLP and RapidMiner. But it's the same data. So this read Excel just reads from an Excel file, which has one column for the class, which is positive or negative, and then another column for the text. Then we use this nominal text just to say specifically that we want to treat our text value as text, and then within this process, documents from data, it's a lot like what we saw last time, a lot of the same operators for text pre-processing. I did go ahead and add in stemming just to make it a little less cumbersome computationally, so we'll have stemmed terms in there as well. So the next thing we'll do is we're going to use 2 different algorithms to generate sentiment classifications. So for that we will use a multiply operator, and what that does is it splits the data set. It just replicates the data set. So when one of those replicates will go towards one model and the other one will go towards another. So there's our multiply. So let's deal with the first one, which we'll use k-nearest neighbors for the first one. No, actually, what we have to do first is apply this cross validation. And this is another one of those operators where you can actually double click and it takes you to a sub operator process. So that's what we're going to do. Though here you'll notice that I changed this now to TF-IDF, like I said, instead of having just frequency count. And I'm also going to add just pruning some words that don't meet a word count requirement. Just again, to the absolute, the max limit doesn't matter too much, but the min limit saves us some computational burden. So, in any case, so now let's go into this cross validation. And now the first thing we'll do is bring in that KNN operator. So here we go. And we'll use 10 nearest neighbors just because. Actually, no, I'll use 5 nearest neighbors, not 56, 5. And I do want to make sure, going back, that we are set to 10-fold cross-validation. Okay. So 5 nearest neighbors, and we'll connect this model here. And this is our training side of things. Now on the testing side of things, we'll apply kind of a general purpose operator known as the apply model right there. So bring that in, bring that in. All right. And nothing more needs to be done here really. Application parameters, nothing relevant to our specific case. And then we'll apply a performance operator. So you have performance. and we can look at classification here. Drag these across here, and then drag this to here and this to here so that we can connect the output. Which one of these do we want? We'll just stick with, these are all the various classification metrics you can have, but we'll just stick with accuracy for now. We'll bring this one too, just to make sure we get a confusion matrix out of it. And that is all there. So now that gives us our KNN model. So let me connect the performance and test results. And now I'll also bring in, like I said, I also want to do a naive Bayesian model. So we put that in here. Spit this here. Oh, my bad. I'm getting ahead of myself. The first thing I'll do is I'll just copy this because the structure will end up being the exact same. Bring this output here, and then within here, all we're going to do is sub out the KNN for a naive Bayes model. Here it is. We're going to connect the ports. There you go. And that's really all there is to it there. Once again, we'll connect test results and the performance. And if I remember correctly, I think that's all we're looking to do. So we'll go ahead and run the process and see what happens. Takes a little bit, but not too long. See it sort of going through the various iterations and batches that it's processing. So the naive Bayesian model finished running here. KNN takes a little longer. That's another thing here, I guess, that I can inadvertently show you, that you can add comments, annotations. Alright, so I went ahead and skipped ahead a little just because the KNN took, I don't know, maybe 2 or 3 minutes and didn't want that dead air. But in any case, here are the results that we have. So this second one is for, let me drag them so that they're comparing one to the other. So this first one, rather, is for the KNN. Accuracy of about 75, so it's pretty good. You have the breakdown of the confusion matrix, the classification matrix, and then you compare that to the naive Bayes, the other one, performs much more favorably. Naive Bayes, barely beats the threshold of 59.46, and even with the slight class imbalance we have towards positive classification, it actually underperforms if you were to consider accuracy as the only evaluation metric, which I suppose you shouldn't, but still. So let's take a look at that. The specific predictions given by the KNN model. So here you go. Here we have an example. So it gives you the actual class, this class right here, and then the predicted class. And what will we see here? We'll see that one's for high confidence. So in other words, when the model was really, really confident that the sentiment was in fact positive, we do see that it's positive, right? And that makes enough sense. As in we see that when it's actually positive, the predictive is also positive. Probably not likely to be the case when we're not so sure as to its classification. And we'll see the same for negative too. So let's order this by negative, and what will we see there? Usually when it's negative, it does a fairly good job of predicting that it's actually negative, though it's not as foolproof as positive. This you can probably see some other examples around here. Can we find one? So this was classified, or labeled as positive. And the actual label is positive, but it was classified as negative, and it's kind of understandable because the word "suck" is in there, and that is we think of that as having a negative connotation. And there are a couple other examples here. But in any case, here we have the matrix, which each of the terms, and that includes the lemmas that we've derived from the stemming with zero or non-zero entry as to whether or not they have a value. So that is a short description of how you would conduct sentiment analysis here on RapidMiner.